All right, everyone. Well, let's get this show started. First off, I'd like to thank you all for taking the time to attend. As those of you who have been members of FXPhD for a while know, we like experimenting and trying new things, and I really want to credit Charles with pushing this idea. He's had some experience doing live seminars, and it's something that we thought could be of real interest to you guys. And we're curious about what happens because we do have a worldwide audience. Time zone things are difficult, but even if we reach a certain percentage of people, we think it will have value. So we'll be really interested in hearing your feedback, whether you like this and so forth moving forward. One thing I want to mention is we'd like to ask each of you on the sessions to go ahead and mute your microphone. There should be a menu item under the audio menu. I think Bradford, your mic is open. I noticed before the session. There's also a mic button, I think, on the little control panel as well. If I hear some audio coming in, I'll go ahead and mute you,
Yeah.
and you won't be able to undo it. So I think Paul Carlin had just muted his, and Bradford. I'll keep pinging you because I'll turn you off. So anyway, thanks for joining us. We'll be doing this in various time zones. Same thing next week. But let's go ahead and I'll turn it over to Charles.
Okay, thanks, John. And thanks for participating, everybody. I hope this is going to be a lot of fun. As John said, we're trying out some new technology. Um, the webinar business, so it's new to a few of us. There may be a few glitches. Um, as John indicated, I've done a lot of presentation in person, and that's a lot of fun. One thing that I do as a presenter is try to pay attention to the audience and figure out what the audience wants to know, what's their background, what's their knowledge base. And for that purpose, having some interaction is a good idea. I don't recommend that technique for beginning presenters. So if you're new to presenting, you should probably wait until invite questions at the end of your presentation instead of during. But when presenting in person, I like to ask for interruptions and questions during the presentation. So I'll do that for this presentation, but to a limited degree. So, if there's something you really want to interrupt on, please do so, either by chat or even by audio. I won't be offended if you want to interrupt by audio. And we'll just give that a try and see what happens. And then I'll just reinforce what John mentioned. It's really, really good if you mute your mic when you're not interacting by voice, because that brings the audio noise level down, makes the audio quality better, and allows people to concentrate more easily.
Hey, one quick thing,
So
Charles.
with that,
Sorry
yep.
to interrupt. One quick thing too. I'm going through and muting people who haven't muted your mic. So if you try and unmute it, you can't. Just under the chat
Oh,
area in your window, you can do a direct chat to me, the organizers only, so that everyone won't see it, or just chat. Hey, my mic's not coming on. Let us know and I'll fix it. Okay. So you
okay,
can do
good.
that in the text chat. So sorry, Charles. Just wanted to mention that.
Excellent, no problem. You should be seeing the screen that I'm sharing, the title card for this talk. So obviously DCT 301, Advanced Color Theory and ACES Workflow. And so in terms of the FX PhD, can we call it curriculum, this course really follows DCT 301, which I did in the conventional FX PhD format 1 year ago. And that I think was called Camera Tech and Color Theory. But now we're going to take that one step further. And I'd like to talk about various color spaces, various color transforms, give you some notion of why we need different color spaces, why we can't just live in one color space all the time. There is one color space that's super important to us. Well, actually, two or three. But I was going to say BT709 is really important for us because that's the standard HD delivery color space. And so we all need to be familiar with that. And BT709 is also very, very closely aligned to the sRGB standard that's the de facto commodity desktop color standard. They share the same primaries, they share the same white point, and so it's useful to be really, really familiar with sRGB as well, and to understand their subtle differences between that and 709. The other color spaces that I'll focus on are DCI P3 RGB. That's the color space for movie making, basically. That's the standard color space in which digital movies live at the distribution, I should say, at the approval, mastering, and distribution stages. So that's where all movies end up. But many of us are involved in the movie production and post-production and DI arenas, and there's some other color spaces. Well, there's native camera space, and that depends upon what camera you're using. And most of us know there's RE log and red log and Sony log and Panalog and SI log. They're all conceptually really, really similar, but different in a few of the details. So during the course, we're going to talk about transforms from those spaces into color spaces that we would use in post-production and DI, and finally then into either P3 for movie mastering or 709 for HD mastering. And sometimes, of course, people make a movie and then transfer it to Blu-ray. So another color theory, color transform we'll talk about is from DCI P3 RGB, which is fairly wide gamut, to BT709 for HD. And normally that will involve a colorist doing a trim pass on the movie. So the colors don't change a lot, but they do change a bit. And then finally, just to give you the context for everything, it's called out on the title of the course, ACES workflow. And I think probably all of you know that ACES is the big deal these days for movie digital intermediate, and even being used in some HD productions. So this is the color, let's call it the color pipeline or the color workflow, really invented by ILM, but then taken up by the Academy, and it's likely to be soon standardized by SMPTE. So we'll talk in some detail about ACES in the later classes of this course. That's the basic idea. So just to give you a little flavor, here's my sketch on the back of a napkin of the ACES color pipeline. And this is new enough that I haven't even polished it up into an official drawing yet. I mean, if any of you who've been following my work, you might be familiar with a couple of books that I've written that have got really polished up illustrations. Over time, I take these sketches on the back of a napkin and work them up into official drawings. But this is kind of the way they start. And my own little personal quirk is that I typically carry a whole set of colored pencils in my pocket. When I'm at the cafe, I take them out and I make these drawings in colored pencil. So let's talk about this ACES block diagram just for a moment. One reason is, well, ACES is called out as a special topic for the course, so we want to talk about it. And another reason is that the ACES block diagram really exemplifies a bunch of the concepts of color transform that we'll be talking about through the rest of the course. So let's see if I can draw on this. So we start in the ACES block diagram with scene tristimulus. Now, tristimulus is a bit of a special word. Um, it refers to linear light. I need to line up my drawing tool here. Um, so linear light means that the code values, and typically those will be from 0 to 4095 in the internals of the camera. Those code values are linearly related to the power in the light that is entering the camera lens. So we'll call that linear light. And in terms of color technology, they're called tristimulus values. And we'll talk about this in some detail later in the course. Now, those numbers, I guess, obviously are 12 bits. And typically, we don't have the downstream infrastructure that will handle 12 bits or even 14 or 16 bits. We don't have that infrastructure well established. You know, there's point products that will do 16 bits, but the interfaces and the storage capabilities are typically less than that, and often 10 bits if you're trying to repurpose HD gear into use for digital cinema. So typically the first step of the color pipeline is an optoelectronic conversion function. And in the old days, we would have called this gamma. So this would have been built into the camera. In fact, still today is built into the camera. And what we're essentially doing is going from a rather deep bit depth in the components down to something like 10 bits, or depending upon your workflow, 12 bits. So these are then non-linearly related. These data values are non-linearly related to the linear light in the scene. Now, coming into DI, and really this whole ACES workflow, it really exemplifies the DI chain. Coming into DI, the first thing we do is we invert that transform that the camera did. So we need to know, what is the camera transform? And this is exactly the red log, RE log, Panalog, Sony log business. We just invert it. And ideally, we will obtain from, the VFX DI community, will obtain from the camera vendor that curve. So whatever the camera did in terms of a log or a power function, the first stage of the transform in the DI pipeline is undo it. And we'll talk in great detail about those transforms as we go. Now, the second step of ingesting into a modern DI pipeline like the ACES pipeline is a 3x3 transform. Now, this transform is done on the reconstructed linear light components. And it's a very subtle and delicate and interesting transform. For now, you can just think of it as the second part of the IDT. But this transform basically maps from one linear light color space to another linear light color space. And in this particular example, we're going from what you might call the native optical space of the camera. So this relates to the camera spectral sensitivities, the red, the green, and the blue spectral sensitivities of the camera. It also relates to the illumination, and it relates to the sensor, the lens, those sorts of issues. So we go from native camera space into the RGB space that we're going to use in the remainder of the DI pipeline. And in the case of the modern ACES workflow, that is the ACES color space. So ACES, unfortunately, refers to two different things. ACES refers to the Academy color encoding system, which is the whole pipeline. But ACES, unfortunately, also refers to the Academy color encoding specification, which is a color space used in the DI chain, and particularly ACES is the color space that this first transform transforms into. So we're going from one color space to another with a 3 by 3 matrix. And to some extent, you'd like to just lock that down with science. And we can absolutely do that. And I'll show you in a few moments just a little foreshadowing of what we'll talk about in terms of color transform science. But historically, this transform might have been controlled with knobs. So I'll draw a little sort of electrical engineering knobs here. These would be the knobs on the grading system used by the colorist. Historically, this in-chest operation would have been done largely through craft of the colorist instead of the science, of the color scientist. So there's one example of a color transform. Now it works out there's another different 3 by 3 transform that lives at the back end of this process, which goes from the ACES-ish color space out into the RGB color space appropriate for a particular display device. And in this diagram, I'm showing you the reference projector of a digital cinema chain. So that this stage would be the DCI P3 RGB space. Whoops, sorry, I overflowed my drawing area. So DCI space. And that DCI space is defined with a different set of primaries than the ACES primaries. And the science of doing that transform is another 3 by 3, which is just built using mathematics. However, the transform isn't quite restricted to the science domain because the gamut of ACES space, the range of colors that you can represent in ACES space, is somewhat wider than the range of colors that you can represent in DCI, digital cinema exhibition space. So there's a little bit, well, there's a lot of science in this output device transform, but there's also a little bit of craft in terms of designing the gamut mappings. Now, in the VFX community, I'll assume that most of us today are fairly focused on the VFX community. So it isn't really a VFX job to mess with the parameters of that transform. But I think it's important that you're aware of what's going on in that transform. And so I'll tell you some of the details of those 3 by 3s. Now, also, I should say, I guess I should have pointed out a few minutes ago, I labeled this IDT, this is the input device transform. And ODT, you can probably guess, that's the output device transform. Now, there's some other stuff within the ACES workflow. There's other color transforms, and I'm not really going to give you the foreshadowing of what's involved there today. Well, I may give you a little bit of that as we go. But I wanted to give you that basic transform pipeline just as an example of the sort of things that we're going to do throughout the rest of the class. So that's one little bit of ACES. And then, well, I guess I'm just going to stream very quickly through 6 or 8 ACES slides, just to give you a notion of where we'll be headed next. So this is a graph, this one in polished up form, showing you the classic 2-dimensional graph representation of the ACES color space. Now, I've shown you on this graph this triangle shaded in gray is Rec 709. So here you have red, green, and blue of Rec 709. And you can talk about the little x and little y coordinates of any of those 3 points. In 709 space, you can construct at the display device any color that lives within the triangle formed by those vertices. Now you'll notice there's colors that can't be represented in 709. They just have too much color, too much colorfulness, if you like. And 709 just doesn't do it. Now 709 is a completely reasonable color space for HD, but it doesn't match the color range of motion picture film. And so when digital cinema was standardized, the color range for digital cinema was chosen to be somewhat bigger. So let me try to just give you a little sketch of that. And sorry, my drawing tool isn't really lined up to be very useful yet. But this will improve as we go. So digital cinema color space roughly looks like this. It too has triangles. It too can be described by the little x, little y coordinates of the triangles, but it goes and gets a bunch of cyan or turquoise colors that are outside the range of 709. And it also gets a bunch of yellows, oranges, golds, and reds in this region, which are not available in HD. Now, just to give you one little example, little Nemo the fish lived at color coordinates out in this region. He was orange. And when the movie Finding Nemo was transferred to Blu-ray, the movie makers were forced to move the little fish to be inside the RGB triangle of 709. So that's another example of a color transform, and we'll talk about such color transform things as we go through the rest of the course. Now you'll notice that I'm highlighting ACES on this slide. Well, the ACES so-called red is way out here at an extreme point, way outside what either digital cinema or 709 HD will do. And this choice was made absolutely deliberately by the Academy. The Academy wanted to pick a color space that encompassed everything that was foreseeable for release of digital movies. In fact, even more extreme than that, the Academy group decided to include all the colors. Now, it isn't the expectation in the near term that we're ever going to be able to display all the colors, but they wanted to build a pipeline that accommodated that in the guts of the color transform DI machinery. Now, this is one of the reasons you have to transform on the way in and transform on the way out, is that it's very sensible and productive and useful to be able to have all of the colors in the middle of the pipeline, even if you can't sense them all or display them all. And I hope that makes sense to you at a conceptual level. And as we work through the next 9 classes of DCT 301, we'll fill in how that works, what that means, what you can do with it. So ACES red is way out here at the corner of this classic CIE horseshoe diagram. Now, ACES blue is also kind of an extreme color. In fact, it is so extreme, it is outside the range of any color that you can possibly produce ever. And mathematically, or even in terms of physics, this corresponds to a hypothetical or imaginary color. You cannot actually make this color. ACES blue is what we call in the color science trade non-physical or non-realizable. And the ACES green is way out here, even off the charts. It is also non-realizable. So choosing those non-realizable primaries allows ACES to cover this entire horseshoe shape of all of the colors. Now, as we go through the course, and and Paul is just asking a question about this. As we go through the course, I'm sure you've all seen this 2D diagram before, although maybe not with the ACES primaries overlaid on it. But we will talk about how the three components of color that are sensed by a camera or even sensed by a colorimeter translate into these two coordinates of the little x to the y graph. And we do this translation into two coordinates simply to allow those things to be mapped on a piece of paper. I mean, ideally, we would be mapping color space in 3 dimensions because color is actually 3-dimensional. But we don't have 3-dimensional pieces of paper, and so we've formed this convention of plotting them in 2 dimensions. And, the x sounds like, the x coordinate, which would be horizontal, and the y would be vertical. But in fact, there are 3 coordinates, and the other one to keep in mind is called big Y. So the color scheme that I'm showing you in this graph, you can think of as being little x, little y, and those are called chromaticity. And then big Y, this is luminance. And I think I'll spend some time the rest of today's class just giving you a little terminology and notation description, because the words we use for these things are complicated and subtle. So that's just a basic notion of where we're going over the next 9 classes, describing the ACES color space, and that's one of, let's say, the 3 really important spaces that we need to talk about. The other 2 being DCI P3 RGB for cinema distribution and BT709 for HD distribution. So we do transforms among all these spaces, but keep in mind, and you can keep it in mind just using as your visual or conceptual reference this diagram, that in 709 space, you can very easily take any color within 709 space, so any of these colors, and the Macbeth color checker plots into 709 space looking like ... like this, and I'll show you where the color checker plots in this diagram later in the course. The color checker doesn't have any colors that are, well, it has one color that's a little tiny bit outside of 709, but roughly speaking, it doesn't have any colors that are outside of 709. Most of these colors are highly, highly saturated and really never found in nature apart from lasers or very obscure, crazy sources. So the further out you go here, the less you have to worry. But we do have cyan, turquoise colors that are available in motion picture print film. And we've decided in digital cinema, in the adoption of the DCI P3 RGB space, to include those colors in digital cinema because that's what our cinema viewing audience expects. Now, if you want to take cinema back into Blu-ray for an HD release in Blu-ray, you have to map those colors. And so Dan is asking, are these transforms lossy? And the answer is, well, if you're completely within the gamut of the destination space, then it's not lossy. You can do 3x3 transforms basically till the cows come home and not worry about anything. But in typical cases that we deal with in DI and VFX, there are lossy transforms. So over the next 9 classes, we'll talk about that in some detail. So there you go. There's just a little hint on what's to come in ACES color space. So let's see what else we have to do. Let me give you a quick intro to color transforms. So we're going to be doing transforms like this. Now, I know some of you are getting frightened now, but don't get frightened. By the end of this class, you're going to know exactly what this means. Many of you will know mathematically that this looks reasonably simple, actually. This is just a 3 by 3 matrix of exactly the sort that we're talking about. And its purpose is to take red, green, and blue in one flavor, and here I'm giving you the 709 HD flavor, and do a little bit of arithmetic. And basically, the arithmetic is simply 9 multiplies and 6 adds. That's all you have to do. I mean, if you've only got 1 pixel to deal with, this takes you 90 seconds on your calculator. Of course, typically we want to do this on 2 million pixels, so we're not going to use a calculator. But the math is fairly simple. This particular transform goes into the CIE big X, big Y, big Z space, which is the color scientists' preferred interchange space. And then there's a piece of math, and if any of you sat through a linear algebra course in first year university, you might recognize that you can do a matrix inverse, and it's just a set of math rules that tell you how to build the 3 by 3 matrix that simply goes the other way. So in this case, we're coming from the color scientists' preferred big X, big Y, big Z space, and we're going into HD 709 space. So I give you this slide up front, class 1, not to frighten you off, but just to say this is the sort of thing that we're going to look at. Not that I want to teach you how to compute the coefficients of these matrices, but just that I think it's important for really sophisticated VFX people, CGI people, to understand what are those transforms, what's the character, what's the flavor, what's conceptually going on. That's my goal, is to teach you that stuff. Now, if you look at this transform, you think, okay, we've got a space here. This particular one is the color scientist XYZ space, but the ACES RGB space is not that far from big X, big Y, big Z. And later on in the course, I'll give you the transform that goes from ACES to 709, and it looks very much like this. But take a look at this transform. It's got negative numbers in it, like this one. And this, if for those of you, and I'm assuming some of you are familiar with this math, that number is basically saying when you take the big Y, you multiply it by minus 1.5, and that contributes to the R. And what that means basically is some of these values might go negative. And obviously all of us know in a classic RGB display space, including the 709 space for HD, the display device can't do a negative number. And the negative numbers that result from these calculations produce colors that are out of gamut for that device. They can't be represented. Now, one quick and dirty and sleazy way to handle that is just clip off the negative numbers, force them to 0. But what you as a VFX artist should know is that that approach runs the risk of chopping image information, and that's really super dangerous. So typically, if you're dealing with a transform that goes from a really wide color space, like this one, out to a, let's call it a moderate color gamut. I'm not calling it wide, and we will talk about wide gamuts later, but if you're going out to a moderate color space, you have to worry about these colors that might lie out of gamut. And you typically will not just clip them. Instead, you'll go through a color transform that's a big lookup table that imposes some gamut mapping. In other words, some warping of the color space here and there to avoid clipping. And again, this is just the foreshadowing. We're going to talk about the details of that as we go through the rest of the course. So there you have just another little tidbit. And then let me give you a final tidbit of what we're going to talk about later in the course. It's what I call log and quasi-log coding, and it's also math, but I don't want you to be frightened by it. Um, so I give you that warning before I show you the slide. So basically, this, and I'll give you this handout in the form of a PDF. We'll make that available for you when the time comes. Let's start at the bottom here on Viper film stream coding. Now, I know that the Viper camera has been discontinued, no longer available. There were a couple of movies made, a couple of Michael Mann movies made with the Viper camera. Grass Valley has now discontinued that camera, but I start with the example of the Viper camera because it's my colleagues at Grass Valley who were the first guys to implement log coding in a camera. And they documented that log coding with this formula, which looks more or less terrible, like it's really super complicated. But the key point is they're starting with the light value in the scene. And I'm sorry, I'm using a lowercase x here, like x is the unknown. This is not the lowercase x color chromaticity coordinate that I showed you a moment ago. My apologies for that, and actually I'm going to change that next time I revise that slide. But the key point, this is the linear light value in the scene. So if you shoot an 18% gray card in the scene, which is something I hope you're familiar with as a VFX guy, that number will be 0.18. And this formula then tells you exactly what that exposure translates into in terms of a 10-bit digital number that's recorded in the image data at the recording of that scene. And I'll make a guess. I don't know precisely what that formula maps into. You could do that as a homework assignment if you like. But that is going to translate into a number something like halfway up the scale from 64 to 940. Now, there's nothing preventing you from going to a number below 64, but you'll notice that 64 has already been added to something here. So there is, the Grass Valley guys have sort of shifted that scale up a bit by adding that 64. And there's also nothing preventing you from going up as high as, well, maybe 1023, maybe 1019, depending. But the key point is these are the numbers that you look at when you get the scene in as, say, a background plate or a live action plate that you work with in VFX. And it's highly useful to take a color chart in the scene and look at what those numbers are, and they're related by this sort of formula. Now, in a later class, I'm going to show you these transforms, and you can call, well, let's just call them log. My word is quasi-log, and there's different variations of it. I will show you what's silicon imaging, what's film stream, what's RE log, and red log, Sony log. They're members of the same family. So this is the other thing that we need to take a look at for color transforms in VFX. It's not all these 3-component color transforms. It's also basically the 1D transforms. And you can implement these as a 1D LUT. And you can implement the 3-space transforms as a 3D LUT. So obviously, if we're talking about color transforms, we also have to talk about lookup tables. So that, I wanted to just give you a flavor. Now, I don't want to make you worried here that this is going to be super heavy math. Some of you, I think, do want to know the super heavy math because for some of you, I think it'll be important to be able to do these transforms, particularly when on set you're able to shoot a color chart and then at ingest or when the background plates are handed to you as a VFX artist, you're able to look at them. And the other thing you want to know is, I think you want to know, when I shoot the 6 grayscale chips of a color checker, what are those video values? How many units is that, or how many IRE units if you're a video guy? I think that's highly useful information. So we'll talk about that sort of stuff. So and again, don't be nervous about how I'm showing you all this math. We're not going to talk about the math. The key point is give you a really solid conceptual foundation for how these transforms work across the whole chain. And that, I think, will be just really valuable for you as a VFX person. I mean, and again, I'm assuming most of you are VFX type people. So there you go. That's the 40-minute mark. And in DCT 301 that we did a year ago, every session was around 40 minutes. I can probably get away with doing 30, but today you got 40. And it is our goal to leave 10 to 15 minutes at the end of each session for Q&A. So I've answered a couple of the questions that came across the chat line already, but I'd be very happy if any of you want to ask a question on the chat, or even just unmute yourself and chip in by audio. We can have a 10 or 15-minute discussion before we wrap. So I see, Nick, you're asking, can we do a survey? Let's do that. That's really valuable. And so let me then try to coordinate a little survey. And let's try to do that with the raising your hand feature of the GoToTraining scheme. So I'll ask about 4 questions, and I think I can't see the raised hands. But John, are you able to take a tally of people who raised their hands?
Yeah, I can definitely do that for you.
I'm sorry, your audio is low here.
I can definitely do that for you, no problem.
Yeah, so let's do that. Yeah, okay, so let's do that. So let me ask 4 questions then. So I'm seeing the answers streaming in on the chat line, but let's do it by raising your hand instead. And you'll have to go figure out with the GoToTraining thing how to raise your hand, but John is going to count. So hands up if one of your primary interests is, well, let's say first, acquisition. So now I'm talking about DIT or camera tech or front-end acquisition stuff. So that's question number 1. Go ahead and raise your hand if that's a primary interest of yours. And John, I'll let you.
We have 4 hands raised on that.
Okay.
27%.
Okay, and then raise your hand if your primary interest is, or I shouldn't say primary, if one of your primary interests is ingest to DI. And you got some hands up?
We have 3 of 15 for that. 3 hands raised.
Okay, and then the one you're waiting for, if a primary interest of yours is VFX mainstream.
And 7 of 15 on that one. 7 out of 15.
Oh, not even, just barely.
Now down to 5 of 15.
Okay, all right.
So
not as many as I would have guessed. And then final question, if one of your primary interests is grading, editing, conforming, finishing.
And that's 6 of 15.
Okay, so that's actually really evenly spread across the whole pipeline. And I'm happy about that because I like working in all those places in the pipeline. I mean, I do my techie stuff kind of throughout that. But it's good to know that we're kind of evenly weighted across the whole thing. So then let's just open the floor to any questions about anything, either by chat or by audio. So cut loose.
And if someone cannot unmute their mic, let me just say, go ahead and ping me on chat and I'll unmute it because I may have muted you from my side.
Hi, this is Neil. Can you hear me?
Just barely. If you can raise the level by 3 dB, that would be good.
Can you hear me now?
It's a little better.
Okay. Basically, just looking at your ACES workflow there, just trying to get a general idea from kind of where VFX would be working in that DI section on the diagram. I'm assuming somewhere in that LMT area, or
I'm sorry, say again the question. I was busy pulling up the slide.
so as somebody who's working like our visual effects house works in a pretty much linear color space. So we basically bring in whatever we have and then we pump it out to whatever the client wants.
Okay.
So I'm just trying to like figure out based on this diagram kind of where we would have our artists be working. Like what area of the diagram?
The art is here.
Okay.
So basically, you're going to be using an IDT that comes in from your native camera space, whatever that happens to be, and that data just gets handed to you, right?
Yep.
And you will have to find, or worst case, build for yourself an IDT that comes into ACES color space. Now, at the moment, I'm assuming you're coming into a linear light color space, but not ACES primaries.
No,
So
we get Cine on and then we generally convert that to linear.
right, but then you do have to worry. I mean, even when you come up into linear, and ACES is linear light space. However, ACES primaries are really wide gamut. So I'm assuming your current scenario is your whole DI pipeline. I'll make a wild guess. You're probably using P3 primaries throughout?
Depending on the show.
Yeah, it depends. P3 or Rec 709.
Oh, that's so if it's an HD show, you can do 709, right? So then for you or any of your colleagues, I mean, the way I see this unfolding is over the next 5 years, slowly, pretty much everybody at the high end just goes into ACES color space in the mainstream workflow. In other words, whether it's a movie or an HD show, I see the world at the high end just going to ACES. And then so you will do a color conversion out of ACES in the ODT. And the ODT will involve a little bit of gamut mapping. So the good news is you will still be absolutely linear light in the pipeline, but now your primaries are going to be wider than they are compared to what you do today. Does that make sense?
Yep, that makes sense.
And so, you know, the other question is that if you also spin out your camera material as background plates for VFX, and that's typically going to be a different facility, then they're going to hand you back VFX shots. I think that over the next 5 years, they're going to figure out how to hand those shots to you in ACES. But in the short term, they're going to hand them back to you in sort of Cineon-ish form. And so, in effect, I think in the short term, you'll probably be transforming that material through something like an IDT for VFX. But in the long term, you want them to just hand you ACES. And so then this transform, and we'll go over this, and you know, I think the way we'll do the course, I think I'll give you the ACES stuff quite early on. Like, rather than giving you all this theoretical stuff in class 2, class 3, class 4, I think I'll just give you all the ACES stuff, class 2, class 3, class 4, and then show you how the theory then folds into each of those boxes at later classes. So we'll talk about the LMT fairly early on. So the LMT is basically grading works on, well, the LMT stands for look, modification transform. And it is not standardized in the ACES set of standards. It's where the knobs live. This is where color grading takes place. And then it's the goal of the ACES kind of standards work to have what's called a rendering transform, and we'll have to talk about this in class 2, which is fixed. So there's one of those transforms, and well, there may be 1.0.1, but it's the goal that the rendering is fixed. We'll talk about that later. So does that answer your question, Neil?
Yep. I'm just wondering
Okay.
what the like full definition for RRT is.
Well, I'll show you next class.
Okay.
And very roughly speaking, if you know CTL, color transform language, or if you know MATLAB, or if you know C, I mean, the RRT looks like a program, but it's got a lot of numbers in it. It's basically 3 or 4 pages of code with a bunch of formulas and a bunch of numbers. But that transform takes the modified camera data, or if you wish, the unmodified camera data. So that's a ... path that doesn't include any look modification. The RRT takes that data and converts it into an output space suitable for viewing. And then there's a bunch of sort of colorimetric textbook transforms downstream, but the RRT, you could call the LMT the art or the look, and you could call the RRT the craft of what a movie is supposed to look like. And then you could call the ODT and the EOCF and those things downstream, you could call them the science. So in class 2, we'll have a long talk about art and craft and science, because it's very important to distinguish which operations you need to do in which philosophical domain. And in film, those lines were kind of blurred, but in the ACES workflow, well, they're not that blurred. So we'll talk in some detail about that. So let me just then quickly cover a couple of other questions that I see on the chat line. Nick is asking, how close is ACES to being finalized? The RRT, you could say, is in a sort of late external beta. At some point, I'm guessing within the next 3 months. But if the road is rocky, it could be 6 months. But I'm guessing in 3 months, I'm expecting the Academy to submit the RRT to SMPTE for standardization. And then the goal is, as I mentioned earlier, lock it down. And we'll see what happens, but that's what I think is going on. And then Ronald is asking about support for ACES by current VFX apps. And that kind of ties in with the previous question. The quick answer is that the major top-tier grading apps, and I want to avoid getting into trouble and kind of classifying which apps I think are top tier, but I don't think there's any doubt that anyone would call Lustre and Baselight top tier, and you can run ACES today. Now again, though, you could sort of call it external beta. So it's beyond the alpha stage, but it's not quite what we call in the trade FCS, or first customer ship, which means, fully supported. It's on, there's training available. There's tech support available from the vendor. At the moment, let's call it late beta available in commercial products expects quite a high degree of technical sophistication on the part of the user. So you've got to be willing to go and invest some energy to deploy the ACES workflow today, but it's happening quite quickly. So there you go. That's answers to those questions. That's taken up our kind of 15 or maybe even 20-minute question allotment. So I'm looking at a duration, not quite an hour, but we were targeting 30 to 40 minutes of kind of class presentation, if you like, and then 10 to 20 minutes of Q&A, and we reached that level. So, John, I think we can declare that class 1.
Yeah, I think that's great, and I think a good natural ebb and flow to it too, as well as just not trying to only hit the time. But yeah, I think it's a good time to get out, and we can touch also on any other questions in the forums or in later classes as well. So, anyway, thanks everyone for taking the time to take part in the live session. We really hope to see you back, and again, the interactive part is I think really helpful for Charles and all of us. So. Thanks so much for taking part in this course and FX PhD.
Okay, and we'll see you next week. So if I remember correctly, John, it's Thursday next week instead of Friday. Is that right?
It is Thursday next week, and same time zone here in the States. And I think the following week we're going to try and push it to people a little further west, or actually it wouldn't be a little earlier in the day, a day ahead of us. So we're going to push
or even
Australia
in Australia.
So,
so class 3 is optimized for Australia time zone. I mean, of course, anybody can participate, but you might not want to get up in the middle of the morning, in the middle of the night. So hoping to see all you guys in 6 days' time.
So much. We'll talk to you soon. Bye.